All right, so we're going to start, if that's all right, guys. Really appreciate you ending your lunch and actually coming in. I do appreciate that. I know it's hard after eating. Everyone's in a food coma. So hopefully this will be an interesting session for you to get sort of into the whole, how do we become more productive with cloud-native developer tools? My name is Grace Jansen. Thanks all if you came to my session yesterday. If you didn't, no worries, it's recorded, so you can still catch it if you really want to. But I'm a developer advocate at IBM based in the UK, if my accent didn't give it away, just a little bit. And I've been doing this for the last 7 or so years. So I mostly advocate within the Java space, so there'll be quite a lot of Java tools within this presentation. However, a lot of them can be applied to other languages as well. So if you're not a Java developer, no worries, there will be stuff in here for you too. Before doing a software development role in IBM, I did a biology degree, because the two go really well together. My knowledge of fish has come in really handy. So if anyone wants to ask me about my weird and wonderful route into technology, feel free to grab me after my session today. I'll be around for the rest of the conference today. So without further ado, we're going to dive into this session. How do we bring the cloud back down to earth to get increased productivity with these cloud-native dev tools? But first, we need to understand why we're doing this. Why do we care about trying to be more productive within our own development, and why are we moving to the cloud? Why are we putting ourselves through this? And I think it comes down to this slide. And I really love Disney, so I try and include it in all my presentations where I can. It's this feeling we get. Hopefully you've seen Toy Story. If you haven't, homework for today, go and watch Toy Story. In Toy Story, we get these lovely aliens, and they have this saying of, ooh, the claw. And I've taken this and edited it slightly, because it's this feeling we get as developers of, ooh, the cloud. The cloud gives us all these exciting benefits and sort of characteristics that we wouldn't necessarily be able to achieve running it in production locally or on our own servers. It gives us things like flexibility, portability, scalability, being able to have increased resiliency as well for our applications. So all of these characteristics are what gets us excited about the cloud, and it's the reason that we're sort of moving more and more of our applications to that environment. But it doesn't always feel like this. If you're as dramatic as me, it might feel more like this when you're trying to actually build cloud-native applications. It doesn't always go to plan, it doesn't always work the way you thought it would, and it gets a little bit frustrating. So hopefully today we're going to tackle some of those frustrations with some of the tools that I'm going to introduce. So what are we trying to, what do developers care about? What areas do we want to focus on in terms of which tools can help with which parts of our daily lives? So in terms of developers, we care about a lot of different things because our role has expanded over the year. So, whereas we would have maybe just focused on sort of pure coding before, we're now having to look at not just developing the application, but also things like writing tests, being able to deploy it effectively, looking at the different environments that we're going to have to do, thinking about infrastructure. DevOps has started to come in. In fact, if we look at the DevOps phrase, there's DevOps, DevFinOps, DevSecOps. I mean, the list goes on and on of how many words can you squeeze into one massive word, because more and more responsibility is falling on the developer. And so we have a lot of different sort of areas in which we could help ourselves be more productive. And normally, we can sort of represent all of the responsibilities that we cover in development in this inner dev cycle. So we've got sort of the creation of our code or applications into that build stage, then into we might be editing it, redeploying it, testing it, and then eventually deploying it into some environment somewhere, whether it's a development environment, staging, or production. And normally, all of this happens within an IDE or editor. Now, we're developers. I would say, and I think it's fair to say, we're quite an opinionated bunch. So you probably all have your favorite IDE or editor, and you probably hate all the other IDTs or editors, and you hate the fact that other people love them. So in this session, I have some demos that I've pre-recorded, and I've tried to use a variety of different IDEs. I really apologize if I haven't used your IDE of choice, but just know that you can let me know afterwards, and I'll try and change it for next time. But I have tried to use a variety here, so do bear with me. All right. So how do we become more productive in each of these key areas in that inner dev loop? there's sort of two ways I think that we can look at how to become more cloud native in the way that we enable this loop. There's one, which is sort of the beam me up approach, where instead of developing on a local machine, you might consider sort of going into the cloud to do this development. The issue with this is that, if you don't have a solid connection, if you've got sort of restrictions in place, like let's say the internet goes down, suddenly you can't code on your application, your firewall breaks, whatever it might be, there's a lot of sort of prerequisites that you need to have in place to be able to actually do this effectively, especially at scale. So the other approach, which is the one I'm going to talk about today, is how do we bring sort of those cloud native features and functionality down to our local machines to make our local machines more similar to what we would be deploying to in production to be able to make us more effective when it comes to that inner dev loop. And for that, we're going to be taking a look at some open source technologies. As I said, I'm in the Java space, so a lot of these are Java tools, but it doesn't mean they're specific to Java. There are equivalents that are available in other languages too, if you're interested in that. So a lot of the demos I'm going to show today are going to use some of these core technologies within them. So the first is Open Liberty. If you're in my session yesterday, you'll have come across this. If you weren't in my session, has anyone come across Open Liberty before? Yeah, got a hand. Matthias, you don't count. Got a couple of others. Cool. Okay, there's a couple. So if you've not come across Open Liberty before, I'm going to ask you a different question. Who has heard of WebSphere? Yeah, more hands. Yeah, okay. So WebSphere was our more legacy product, but as many of you may know from using it, kind of clunky, kind of big, kind of annoying and awkward. So what happened is we created a brand new project called Liberty, offers really similar functionality. So it's a cloud native runtime or an app server, whatever you want to call it, but it's modular. So it's plug and play architecture, makes it really small and performant for the cloud, and then we open sourced that in 2017. So that's what Open Liberty is. And I'm wearing it on the t-shirt, so you can tell I love it. And then we've also got things like MicroProfile. So MicroProfile is an open source community-driven specification that builds on top of the Java EE specification. So it offers enterprise Java apps additional APIs that are really designed for the cloud and for microservices. And then we've got Jakarta EE as well, which we're going to be using in these applications I'm demoing. And this is really the sort of open sourcing of Java EE. So if you're using enterprise Java, you may have come across this as well. So in terms of the inner development cycle, we're going to take a look at each of these different boxes I've identified here. So create, build, edit, test, deploy, and take a look at what tools can help us with this. So the first of those is create. When it comes to actually creating code for our application, what can we use to be more productive? And a great starting point is starters. So starter projects available from various different open source runtimes and frameworks. So the first one I've got up here is MicroProfile. So if you've not come across MicroProfile before, let's say you're interested in the open source specification, but you're not sure which runtime you want to use, because the great thing about MicroProfile is it's created by and supported by lots of different runtimes. Not just Open Liberty, you might have heard of Quarkus, for example. You might have heard of Payara, JBoss. There's lots of different frameworks and runtimes that support this specification. So there's a starter project available from the MicroProfile community. And the nice thing about this starter project is it's actually available as a VS Code extension as well as being available online. So it's really easy to get started with both this and the Jakarta EE and Open Liberty starter kits. It's literally drop-down menus if you're using the web framework. So all you have to do is fill in what level of MicroProfile do you want to use, what level of Java do you want to use, which runtime do you want to use, what build tool do you want to use, Maven, Gradle. Once you make these selections, it will automatically create a zip file that you can then download and open, and it's got the bare frameworks of an application ready to go for you. So if you've got brand new starters into your company, this is a fantastic way to get them up and running really quickly with just a few drop-down options. I have a demo here, but it's basically just what I explained. So by downloading the plugins that are available, this is in IntelliJ, for example. So hey to all my IntelliJ fans. VS Code, it's coming. Hold your turn. So in this, we've got the extension pack for MicroProfile, which includes that starter application or starter project to enable you to try that. We've also got the Liberty Tools plugin, which allows us to be able to very easily see what's running in Liberty in our IDE through a dashboard. So in this, at the top here, I'm using the microprofile starter project, selecting my drop-down options as you can see them appearing in that top selection box. So in this case, I'm building a very basic application with microprofile, Takata-E, and Gradle. And once I select which microprofile APIs I want to use, because again, this is a plug-and-play architecture, so I can pick and choose which ones I want to use. As I said, it will then ask me where do I want it stored. It will then start generating this project for me, and this is all in real time. This has not been sped up. It's just I'm having to talk quick through this. And as you can see, in just a few seconds, we've already got a starter application ready to go. So from there, we can start exploring more in what we want to create in our own Java applications. And you can see in the Liberty dashboard here, we can start to see the Liberty application and sort of be able to play around with it as well. So that's a really great tool for that create stage. Next, we've got the build stage. So when it comes to building our application, traditionally, you might think of Java as kind of a slower language in terms of being able to build and edit on our app, but actually sort of advancements and innovations that have been happening within the Java space have made this much faster and a much more iterative and agile process. So many runtimes nowadays have this ability to be able to have a dev mode. So in Quarkus, I think it's called hot reload. We call it dev mode in OpenLiberty. What this means is that instead of having to tear down your server and rebuild and redeploy it every time you want to see a code change, the server is automatically listening for code and configuration changes so that it can then sort of recompile and reconfigure those particular classes that have been changed in real time and redeploy those, or rebuild them, I should say. So you don't actually have to tear the whole thing down to see those changes. It makes it really great for iterative development. So being able to see those changes in real time and understand the impact and effect that they can have on your application. The nice thing with this is that for Liberties, it comes as a Maven and Gradle plugin. Again, it's a very similar plugin for things like Quarkus. They work in very similar ways. And it allows you to have that continuous testing and continuous integration. Now, if you're not using a runtime that offers this, which I would say is fairly rare, a lot of the newer runtimes are offering this functionality. There is a separate project that's been created by a colleague. They're not from IBM, just a friend of mine called Adam Bean. You might have seen his videos online. Adam's created this project called Watch and Deploy. It's essentially a very similar technology. It allows you to be able to watch out for file changes and redeploy dynamically. But it is for sort of a wider range of runtimes if your runtime doesn't offer it. So you can plug and play this in if you want to use it. The GitHub repo is linked here, and I will share my slides afterwards. So that's the build stage. Next, we've got the edit stage. So now that we've got an application, a basic application, and we're able to deploy it or build it sort of very effectively and iteratively, now we want to go through and actually make some specific changes to our application to make it unique to us, to add value as a developer. So when it comes to the editing stage, obviously the first stage we want to consider is what plugins are available in our IDE or editor of choice to make this more effective. Often you can utilize sort of either language-specific, runtime-specific, or even sort of framework-specific plugins. So I've already shown one in that video earlier for microprofile. There's also Liberty tools available. Really, there's a huge range of plugins that are available to really help you with this sort of iterative extension of being able to make it specific sort of shortcuts or specific things to your application in your IDE. There are some specific ones I wanted to call out here that can really help with that editing stage, especially if you're unfamiliar, for example, with many of the open source technologies I've mentioned. So if you're using microprofile, for example, and you've never used microprofile before, there's a really great coding assistance that you can utilize that can actually help to give advice on sort of microprofile in your project. So this is a really short acronym, really easy to say, LSP for MP, because we're developers and we just love acronyms. So this stands for Language Server for Microprofile. It is at the moment an incubator project within the Eclipse Foundation, so that's where Microprofile and Takata-E sits, so it makes sense that these language server plugins also sit in the same foundation. What this allows you to be able to do is to essentially provide in-editor language features, so things like code completion, snippets for popular APIs, even diagnostics and quick fixes. So they can be really helpful if you're unfamiliar with the specification to be able to help you dynamically fix any bugs that you may have accidentally introduced, or be able to help you complete code if you're using an API you've not used before within your application. There is a really similar extension or plugin that's available for Jakarta EE. Again, very short acronym, really helpful. Language server for Jakarta, so LSP for Jakarta. And the way that they can be used is a little bit like this. So in this application, you'll see I've got my terminal at the bottom here. I've already started Liberty in dev mode. So I mentioned dev mode earlier as another tool you can use. So it's dynamically listening out for any changes within my application. In this case, I'm using the language support for microprofile, so the LSP for MP tool. And here I'm trying to create a cafe controller class. I want to use the @REST client annotation that's available from microprofile REST client, one of the APIs from the microprofile specification. But right away, I start getting warnings. So for example, I didn't have the @inject imported into my class, but I'm already getting help in terms of, what was wrong with my code, what did I need to do to fix it, and even being given the quick fix to be able to go and correct that. I also needed to be able to have an @inject. That was another error that my application, the language support server, caught because I needed to use a CDI bean to be able to use that @inject annotation. So all of these are errors that could very easily creep into your application and mean that it wouldn't work properly. But with tools like the language support, we can really easily be able to detect and edit that and make those corrections when needed. As well as support for sort of you directly coding in your IDE, there's also support for things like code generation. So this is kind of, what if you want to generate snippets of code or generate boilerplate code? Are there tools to help? And yes, there are. So code generator tools like OpenAPI tools, you can actually generate things like microprofile REST clients directly from OpenAPI documentation. So you can either use this as a command line interface tool or as an IDE extension. So in this case, I'm using the IDE extension, again, just to demo. This is in IntelliJ. So in here, I'm using the microprofile REST client generator, and my aim is to generate a REST client that will then connect into my REST service. And we're going to be using the generator for this. So it's going to prompt us for an OpenAPI document. We're then going to pass it that OpenAPI document from the REST service, my hello controller. We're then going to click generate. We're going to verify the package name that we want to use. And this is basically going to create a whole REST client interface based off of that OpenAPI document. So let's have a look at this. So here we've got the drink.java. So you can see my imports there. We're just going to delete those. So in the APIs folder, we do get some exception classes, and the default API class, the bulk of what we need to get this working, this is basically the whole REST client interface. So we can see it has all of our endpoints with the right post or get annotations from our REST service as well. So let's take a closer look into this. So I don't need that one. I think I deleted that. Yeah. So you can see I've got all of the post and the get, all of the APIs and the endpoints that I need to access. All we need to do is to make use of this default API class in order to control our REST service. I need to add in a base URI to be able to use this. So I need to point it at the base URI for the REST service for this application. So I'm just going to add in my base URI here, which I can again access from my OpenAPI documentation, copy this over, paste it in, and you can see in just a few steps, just from having that OpenAPI documentation, I've been able to generate a whole new REST client applications in my application. So it's really helpful for being way more efficient, especially if you're already using OpenAPI documentation to be able to do this. Okay, moving on to test. I know this is a lot of tools, but I'm rapidly going through them. Hopefully you're keeping up. Let me know if you're not. So testing. So now we've gone through creating some code, building that code, editing that code, and of course, we're all excellent developers, so we spend a lot of time testing our code. nodding in the audience, yes. So in terms of testing, you've obviously got the usual suspects when it comes to testing. You've got things like JUnit tests. Hopefully we're all making good use of those. We've also got things like Arquillian, and sort of the newest kid on the block is test containers. Anyone come across test containers before? A few hands, great. Okay, so for anyone who hasn't come across test containers, this is a really useful tool to be able to leverage containers locally on your own machine to better replicate that production environment. So it's really an open source framework. It's sort of been, it was created as a community sort of project, and it's been built upon ever since. There was a company called Atomic Jar that sort of really took it under their wing. They were a startup. They got acquired by Docker, so Docker is quite heavily invested in this now. Test containers is really about, as I said, having the ability to be able to have light, throwaway instances of containers on your local machine so you can better replicate that production environment on your own machine. So if anyone knows the 12 or the 15-factor application methodology, really getting closer to that dev prod parity or application parity. So being able to, there's lots of different ways that you can sort of utilize test containers. Here's an example architecturally of sort of what it's trying to achieve. So the benefit of being able to have containers running locally on your machine for testing purposes is that when you're doing things like integration testing, it's actually testing it in a way that it would be behaving in production. So you could have, for example, a MongoDB database that your application is reliant on, and you're able to test the integration between those two separate containers as it would be perhaps in your production environment. And the top box here is sort of what you'd expect in that testing environment. So having those integration tests basically replicate what your end users would be experiencing in production. So test containers is definitely one to look at if you've not seen it before. I would show a demo of this, but it would take quite a long time. I did pre-record it, and given the 40-minute limit, I was like, let's not go through all of that today. That's like a whole session in itself. However, if you are interested, we do have a guide that you can do in your own time. It takes about 20 minutes that gets you up and running using test containers so you can have a go. The nice thing about this is you can do it in your own environment, so on your local machine. Just make sure you've got the prerequisites that are in the top left-hand corner, right-hand corner for you. But if you want to run it in our cloud environment, we also have a cloud environment, which I'll talk about a bit later, that you can try out as well. Okay, so we've talked about the creation, the building, the editing, the testing, and now that's sort of the end of our loop, and then we're going to talk about the deploy, that arrow that went outside of my IDE box. So what can we use, what cloud-native tools are available to help us in this stage of the dev loop? So has anyone come across build packs before? Couple of hands, not many, okay, great. So cloud-native build packs. This was a project that was initiated by Pivotal and Heroku. Heroku is actually the creator of the 12-factor app methodology, so kind of right up their street. Back in 2018, and then it joined into the CNCF in 2018 as well. And it's sort of been there ever since, being developed and sort of built upon. The project really aims to unify the build pack ecosystem. So it's all about sort of providing a framework and runtime support for applications that means that instead of needing to write and manage Docker files, you can essentially use container images and sort of layers that can be knitted together to create your images using the pack CLI. So it enables things like, the benefits include the fact that it enables things like modern container standards, so things like OCI image format, and being able to take advantage of the latest capabilities of things like image layer rebasing on Docker, for example, API v2 registries. All of this is enabled through build packs. If you're looking at a feature comparison, maybe you're using something like source to image, maybe you're writing your own Docker files right now, or maybe you're using another tool that might be in this list, it might not be in this list. But the nice thing about cloud native build packs is, as I said, you don't need to have a Docker file, so you don't need to maintain and update it. You can have things like advanced caching, so you can use things like built-in caching to improve your performance and to quickly rebuild your application. Another huge benefit, especially with the growing concern around security, is that it enables you to be able to have a software bill of materials, or SBOM. So being able to know exactly what's within your application. So if there's a potential vulnerability, you'll know if you're using it or not and if that potentially affects you. So a massive benefit there, especially on the security side. There's also things like auto-detection, rebasing, reproducibility as well. So being able to reproduce the same image again and again to be able to test effectively. So if you did want to have a closer look at this, because I know it's a little small on the screen, you can go to buildpacks.io/features, and it gives you this comparison. So if you're already using a tool and you want to know, is cloud native build packs for me, then check out this comparison list and see, are the differences potentially going to be beneficial to your own application and organization. Okay, so Cloud Native Build Packs is essentially a specification, and an implementation of this is Paquito Build Packs. So the Cloud Foundry sort of team came together, took a look at the Cloud Native Build Packs, and decided to create this project, Paquito.io. It's based on the former Cloud Foundry Build Packs, but Paquito is an implementation of that Cloud Native Build Pack interface specification. So it uses that under the covers. The nice thing about Paquito Build Packs, and all my non-Java people in the audience will be relieved to know, this is a tool that isn't just Java specific. Woo! So this tool can be used with Java, it can, but it can also be used with .NET, Go, Node.js, Ruby, or PHP. So lots of different languages available with the Paquito Build Pack project. We use it within the Open Liberty runtime to, again, allow you to be able to build your applications and deploy them with Cloud Native Build Packs. The way it works is the Paquito library build pack essentially provides the Open Liberty runtime to a workflow. That workflow then produces an Open Container Initiative, or OCI image, that can then run just about anywhere. So wherever you want to deploy it, making it really great for that flexibility and portability that we want when it comes to cloud native applications. So you kind of take your source code, utilizing Paquito build packs, you're then able to sort of send it through the pack CLI and be able to create your OCI image using those different layers that are sort of knitted together. It's really easy to get started. So this is from a blog we have on the Open Liberty website, just to give you an idea of what would be required. So in here, we specify the fact that you need a builder. So a builder is an image that contains all the components necessary to execute a build. So it's basically composed of several different components, normally 3. The first of that is a set of build packs. So that provides your application's dependencies. The second is a stack, which provides the open OS layer for your app image. And the third is the CNB lifecycle, which basically puts everything together to produce your final app image. So in this case, with the Open Liberty one, we're just using the base builder and then adding to it to customize it for Open Liberty. I do have a demo for this, and I think I've got time for it. So in here, I've got a very simple application. This is just showcasing, it's just an application that's got a system microservice, and it basically just scrapes my system properties. So super simple stuff. We're going to very quickly build my application, I believe. Yeah. Right now, we have no specific config, I just want to point that out, in the application for Paquito currently. We've just basically got a very simple application. We've got a pom.xml, so within the Liberty part of that directory, we've got the Liberty-specific server.xml information. So what we're going to do is we're going to use this pack build command to specify in some environment variables and the fact that we want to use stuff like the OpenJ9 build pack. The important thing here is we're not actually having to specify that we're using the Liberty build pack or anything, because it's actually picking this up from the directory structure. So in the app, if we go to our server.xml, Paquito knows we want to use the Liberty runtime because, as you can see, we're specifying in here, we are using Liberty. So you can see like sample Liberty there. Paquito will then go down, and what it's going to do is it's going to pull individual images and output a production-ready image. Again, no configuration needed. We're just pointing it at the source code for this particular application. So now, once this runs, we're basically going to run the application. There we go. You can see it starting to run now. And we should see our application started up when this all finishes. Give it a bit of a minute. I know this demo is slightly longer, so do bear with me. There we go. Okay. So we can now go to our application endpoint for the system properties, which hopefully I'll do next. Oh, I haven't run it yet. Running now with Docker in this case. Give it a bit of a minute, sorry. Okay, we can see it's up and running. Now if we go to our endpoint, so system/properties, that's just the endpoint that we've opened up for this particular application. So we can now see that system properties of the container this app is running in. So you can see that's all my system does. It's just a very basic application. So in this very short period of time, I know it felt a little longer because I was pausing there for the video, but essentially in what's been, a couple of minutes, I got my application up and running with Paquito build packs without any code or configuration changes to my application, got the JVM and a runtime, built a container image and deployed it in Docker. So pretty quick from that perspective. So that's the deploy stage. Now, there was one last tool I wanted to bring up, which kind of spans multiple of these sort of different elements within that inner dev loop, and that's telepresence, which is kind of a new tool that I've come across and seemed really exciting, so I thought I'd share it with you here today. Has anyone come across telepresence before? A couple of hands, yeah? A few. Okay, so for those of you who haven't come across telepresence, this is really, again, about, it is essentially what I've been trying to describe here in my presentation of trying to bring the cloud into your local machine, bringing that cloud down to development. So it's enabling fast local development for Kubernetes and OpenShift microservices. It allows you to be able to swap a pod that's running in Kubernetes with a service that is running locally. So all requests to that pod in Kubernetes are essentially redirected to the local URL and port. At the moment, it's a CNCF project, and the nice thing is that, again, it helps to accelerate that inner dev loop. It allows you to do things like shifting your testing left and use your existing workflow without having to change that at all. Now, there's a couple of links that I put here to some blogs and examples of this being used for applications if you did want to go and check them out. A quick summary of how it works, in case you are interested in this project. So telepresence architecture looks a little bit like this. So essentially there are two core architecture components. You've got the client side telepresence binary and the Kubernetes side, so the cluster side, traffic manager and traffic agent. So you can see where my diagram is labeled 1 here. Here is where the telepresence connect command can utilize the traffic manager to essentially establish a two-way proxy tunnel between your local development machine and your cluster. So that allows you to be able to access your remote Kubernetes services as if they were running locally. Then step 2 on my diagram here, it essentially allows us to be able to run, if we run the telepresence intercept service name, that then triggers the traffic manager to install a traffic agent proxy container that runs within the pods that's then associated with the target services. So it allows us to be able to route all of our remote traffic to our local dev machine for development and testing. So it's a really cool tool. I'm just starting to get to use it myself. I'm finding it really interesting. But again, a great example of trying to bring that cloud down into our development environments to make us more sort of close, get us closer to that sort of in-production testing, in-production development on our own local machines. So I know that was a whistle-stop tour through a lot of different tools here, but hopefully what I've shown you is that there are a lot of tools out there, and it's a growing list of tools that are trying to bring that cloud-native environment down into our development so that we can be closer to it and be more effective and productive when it comes to developing and building cloud-native applications. This is hopefully a semi-useful summary of all the tools that I've gone through. If you're interested in sort of runtime-specific tools, microprofile-specific tools, or Jakarta-E-specific tools, they are on this list. And obviously, I mentioned the fact that many of these tools are available as equivalents in other languages or can be used with other languages, like Paquito, for example, and telepresence. If you want to give it a go yourself, so a lot of what I've talked about involves our runtime. So a lot of the demo apps I showed are run on OpenLiberty. As I said, we are open source, and we are quite proud of the fact that we've got a ton of guides online. So if you're interested in anything microprofile, Jakarta-E, Java, OpenLiberty, or any of the technologies I've mentioned, except telepresence, we don't have that one yet. Getting there. But we have a lot of guides here that are freely available for you to use that teach you all of these different APIs and open source tools. So please do give them a go. Let us know if you like them. Oh yeah, I did a QR code just in case. I've learned from my previous talk that people want it straight away. So yeah, if you want to check them out, you can. The nice thing about our Open Liberty guides is that most of them can run in our online environment. So we have this interactive cloud-native lab environment, so you don't actually need any prerequisites on your local machine. You just need a browser. You can get up and running and trying these guides in literally like 2 minutes. Makes it really super easy. If you want any other resources, because I haven't given enough homework today in this session, then I've got a ton of resources you can check out. Again, I will be sharing the slides, but if you want to take a photo, feel free. There's one, there's another. I can see people with their phones. I'm terribly sorry for all the homework. And because I learned from last time, my slides are already available. Yes, I was prepared this time. So if anyone does want the slides, they are available on SpeakerDeck. If anyone has any additional questions or queries or wants to find out more about the technologies I've spoken about today, I will be around for the rest of the conference and will be happy to have a chat with you. So with that, I'm going to say thank you so much for joining me today on my whistle-stop, super quick tour around all of these cloud-native tools. Thank you very much.